All right, guys, chapter 1, section C. We're going to talk about rationals and absolute value equations. I'm going to go through the rationals fairly quickly because we've already done this in the prerequisite chapter. We got common denominators and all that. We were adding and subtracting. Now we're just solving, so it takes one extra step. So we're going to have to find the LCD, your least common denominator, multiply each term by it. And when you do that, you'll end up canceling out the denominator. I'll show you that in 1 second. And we always have to check for what? Extraneous solutions, always. All right, so let's look at this, all right? I am adding and subtracting fractions. How do we do that? With a what? Common denominator, okay? So understand, and again, we're going to go through this a little quickly, but there is a 1 underneath here, correct? You guys with me? Okay, so what's a common denominator going to be between 4x plus 1 and 1? Okay, so over here, I'm going to write my common denominator, 4x plus 1, and what'd you say the other one was? And the 1, so just all together. So do you have to write the 1? No. Guys, once you get everything to have a common denominator, the denominator drops off because you've made the left-hand side and the right-hand side of the equation equivalent. So what I'm going to do here is we're going to reference the right hand over here with our fractions on the left. We're going to see what each fraction has and what each one is missing. So my first fraction here has the 4. What is it missing? X plus 1. So I'd multiply the bottom and top by x plus 1. Everybody agree? Okay. My second fraction here has the x plus 1. What is it missing? The 4. Multiply bottom by 4. And then my third fraction on the other side of the equal sign has the x. What is it missing? The 4 and the x plus 1, right? So 4 and x plus 1. Do you guys now see that every denominator is the same? Once you have it all the same, you can just cross it off. The denominator drops off. So I'm going to rewrite this so it's just a little cleaner. It's 4x plus 3 times x plus 1. Agreed? Minus 2x times 4 equals 4x times x plus 1. Or 4, I'm sorry. Hold on. Time out. Yeah, in my mind, I went and did it ahead. Can I go ahead and distribute this? Or you guys want me to write it as 4x and then x plus 1? Question, Mia.
Why did you put 4 and then instead of denominator 4x plus 1 and then 1?
Just because I was showing you guys that I took each piece. You don't have to write the 1 there.
You don't have to write the 1.
No. I was just showing you that I was taking each piece. All right. Did I clean everything up on the top? So now, guys, it's just a basic algebra problem. Yeah, we're going to FOIL here. What's 4x times 4x? 4x times x. 4x squared. What's 4x times 1? Plus 4x. What's 3 times x? 3x. And 3 times 1 is plus 3. Minus what? 8x. Equals, over here I have 4x squared plus what? 4x, right? We distribute. All right, so clean up the left-hand side. We have 4x squared. I have a 4x and a 3x, which gives me 7x. Minus 8x. So minus x plus 3. You guys agree? Equals 4x squared plus 4x. Can we get rid of the x squareds? If I subtract 4x squared from both sides, what happens? It cancels out. So I'm left with negative x plus 3 equals 4x. So what should I do? Okay, let's add x to both sides. So 3 equals 5x. What does x equal? What does x equal? 3 over 5, 3/5. Good. Now, can I just assume that my answer is correct? No. All right, with rationals, there's a couple things you need to look for. What is the most important thing you need to look for with a rational? Denominator does not what? Equal 0. If I take 3/5 and I plug it in right here, 3/5 plus 1, is that going to give me a 0? No. You want to go back and check the entire thing, feel free. If we have time at the end, I will come back, but I want to make sure. But you guys should throw your answers back in to check. But when we deal with rationals, the biggest thing is that your denominator does not what? becomes 0. All right, let's look at the next one. Again, you can do this a couple different ways, guys. I like to just say, okay, let me look at all of my denominators, and then over here, I'm going to write down what my common denominator would be. What is my common denominator going to be between x minus 4, and 1? X minus 4. You guys agree? So let's look at what each fraction has and what it's missing. My first fraction has the x minus 4. Do I need to multiply it by anything? My first fraction right here, my denominator has x minus 4. Do I need to multiply it by anything? No, so I'm just going to write my x, and I have an equal sign. My second fraction right here has the x minus 4. Do I need to multiply it by anything? No, so I'm going to write my 4. And then my last one right here has the 1. What is it missing? X minus 4. So I have to multiply the bottom by x minus 4, then I multiply the top. Now that all the denominators are the same, I can cross it off, and I'm left with over here 4x minus 16. I distributed this 4. Everybody okay with that? Okay, so if we're going to solve, I have x equals 4 and a negative 16 is how much? So 4x minus 12. Subtract 4x from both sides. Agreed? Okay, so I have negative 3x equals negative 12. So x equals what number? 4. Okay, good. X equals 4. Can we go to the next one? What, why not? Okay, well, let's check it. What happens when I plug 4 in? My denominator becomes what? So what is the correct answer to this question? No solution. Very good. And again, I know I'm going quickly through this, but we've already done rationals. We just haven't had an equal sign. But the same thing applies. All right, let's look at the next one. What's one step I should take before I start trying to get a common denominator? We should factor. Let's always factor to our simplest form, and then we can find our common denominator a little easier. All right, so what's my common denominator going to be between x minus 2 and x plus 2? X plus 2, x minus 2. I'm going to write it over here. X plus 2, x minus 2. Because what we're going to do is we're going to make equivalency on the left-hand side and the right-hand side. And then we're going to be able to just cross those denominators off. So again, let's go through the motions. Let's look at our first fraction right here that I'm pointing to. My denominator has the x minus 2. What is it missing? The x plus 2. So what you do to the bottom, you do to the top. Good. My second fraction has the x plus 2. What is it missing? X minus 2. Good. My third fraction has both of them. Are we missing anything? No. So my denominator now I can get rid of, and then I can clean up the top. So I have 3 times x plus 2 plus 1 times x minus 2 equals 12. Everybody okay? Guys? Okay, distribute. 3x plus 6 plus x minus 2 equals 12. What's 3x and x? 4x. What's 6 plus, minus 2? So plus 4 equals 12. Subtract 4 from both sides. 4x equals 8. Divide by 4, what's x equal? X equals 2. Okay, good. Move on. Why not? What happens when I plug 2 into my equation? My denominator becomes 0. Therefore, x equals 2 is actually not a valid solution. What is my answer here? No solution. Good. How you guys feel? Are we okay? All right, next ones are a little more challenging. Same concept nonetheless. Okay, this is probably the hardest one on the whole page, number 4. Why? Because it's long. What should we do with all of our denominators before we try and figure out what the common would be between them? Tell me. Okay, good. Factor. What's my first denominator going to factor to? X plus 2 and x minus 1. You guys agree? Okay. What about my second denominator? X plus 1, x minus 1. Difference of perfect squares. Great. And what about my third denominator? What can I take out? I can take out a 2, and then I'm left with x squared plus 3x plus 2. Does that factor? So I have x plus 2x plus 1. Yeah? All right, so none of that was real hard. You guys did a great job with that. Finding your common denominator isn't going to be that hard either. Keeping yourself organized might be the hardest part. So why I say sometimes I write off on the side what my common denominator would be. What would a common denominator be between all three of these things? I have to have a 2, good, because one of the fractions has a 2. What else do I need? I need an x plus 1. I need what else? An x minus 1, and what else? An x plus 2. I took little pieces of each one, because they all have to be the same. So now that I can look and I can compare, I'm going to look at each fraction separately, the one where my numerator is 3. I have the x plus 2 and the x minus 1. What am I missing? I'm missing a 2, and I'm missing a what? X plus 1? You guys agree? Okay, so 2 and the x plus 1, good. My second fraction has the x plus 1, x minus 1. What's it missing? What's it missing? The 2 and the x plus 2, good. So 2 and x plus 2. My third fraction has the 2. It has an x plus 2. It has an x plus 1. What's it missing? An x minus 1. Look at my denominator. Do all three of them have all of the stuff in them? Yes? Then we can cross it off. Once you've made equivalency on the left-hand side and the right-hand side, it's gone. You don't have to worry about it anymore. So now we can just clean up. I'm going to say 3 times 2 is what? 6. So this is 6 times x plus 1. What is this sign right here? What's the sign in the middle? A minus. Good. Make sure. So you have 1 times 2 is 2. And then I have x plus 2. And then I have an equal sign. And then I have 7 times x minus 1. If you guys want to already go through and distribute, you're welcome to do that at that point if you want to. I just want to clean it all up real quick. So now let's say 6x plus 6 minus 2x minus 4 equals 7x minus 7. You guys agree? Everybody okay with that? All right, clean it up. What's 6x minus 2x? 4x. What's positive 6 and a negative 4? What kind of 2? Perfect, good. Equals 7x minus 7. Now what? Okay, subtract 7x from both sides. I agree. And then what? Subtract 2 from both sides. Agreed. So I have negative 3x equals negative 9. So all of that work to tell me that x equals what number? 3. Now, before you pat yourself on the back and say, whew, what do I need to do? Check. What do I need to check? If your denominator is going to turn to 0, all right? You should go through and actually check to make sure that the left-hand side equals the right-hand side. Because that way you can check, you can you can check to see if you made mistakes. Sometimes you can catch a little error there. But the biggest thing, if you're not going to check the whole thing, which I think you should, but the biggest thing you need to absolutely make sure of is that your denominator does not become 0. If I plug 3, excuse me, into any of my x values, do I get 0? No. But you should go through the whole checking process. All right, 2 more of these, and then we're moving on to the next part. Anybody see anything we need to do first? Anything? Can I factor anything in the denominator? What does this fraction become? X times x plus 1. Good. Now, guys, remember, this x plus 1 is stuck together. You don't just add a plus 1 to the fraction that has a 2 as a numerator. You have to make sure they all have the same denominator. So what's my common denominator going to be? X and x plus 1. Good. So let's figure out what each fraction has and what it needs. My first fraction has the x plus 1. What is it missing? The x. So I multiply the bottom by x and the top. Good. My second fraction has the x. What is it missing? X plus 1, what you do to the bottom, you do where? To the top, good. What about my last fraction? Do I have to do anything? No, it's fine. So now that our fractions all have the same denominators, we can cross them off and just clean up our algebra. So this is, I'm going to move this x to the front. So I have x times 4x plus 3 plus 2 times x plus 1 equals 1. You guys with me? Okay. So what's x times 4x? 4x squared. What's x times 3? Plus 3x. 2 times x is 2x. 2 times 1 is 2 equals 1. So I have 4x squared plus what? Plus 5x plus 2 equals 1. What's my next step? Subtract 1 from both sides. Perfect. So 4x squared plus 5x plus 1 equals 0. Now we check to see if this does what? If it factors. What are the factors of 4 that multiply to give me 4 but add to give me 5? X plus 4, x plus 1. Great. My a term is not 1, so what should I do with it? Divide both of these by 4. Perfect. So I am left with x plus 1 and 4x plus 1, both equal to 0, yeah? So now if we solve them, x plus 1 equals 0, 4x plus 1 equals 0. So I have x equals negative 1, and I have x equals negative 1/4, yeah?
Since 4x squared is equal to 2x and 2x, couldn't have been 2x plus 1 and 2x.
No, no, because the middle term has to be 5, and when you FOIL that out, the middle term would have been 4. Yeah, good thinking though. No, it's good thinking. All right, so I just circle these and move on? Yes or no? Why not? Why? What happens when I plug negative 1 back in up here? This becomes, the denominator becomes 0. That's not going to work. Negative 1/4 is okay. When you plug it back in, your denominator does not become 0. Should you go back and check and just make sure negative 1/4 satisfies your whole equation? Yes. But for the sake of time, I'm not going to do that right now. All right. I'm going to walk you through this problem, but you guys are going to have to do all the thinking. I mean, I already know the answers, but you still have to do all the thinking. All right. What does the third fraction say for a denominator? 2x minus 3 what? So this means I have 2x minus 3 times 2x minus 3. Do you guys agree? Okay. So between these three rationals that we have, what is our common denominator going to be? 2x minus 3, how many times? Twice. All right? It has to be twice, not just one of them. It's got to be twice. So when I go through and figure out what each fraction has and what it needs, what is the 6 missing? 2x minus 3's. I agree. So if I multiply the bottom here. What is the second fraction missing? 2x minus 3. Agreed. And what does my third fraction need? Anything? No. Okay. So my denominator is the same. I can get rid of it. So I'm going to write this out. I'm going to write the whole thing out. You guys can simplify where you'd like. I'm going to write the whole thing out just so everybody in here can see it. Equals 7 times 2x minus 3 plus 3. Is everybody with me up to this step? Okay, so now when we FOIL, I'm going to leave 6 hanging out here. 2x and 2x is going to give me 4x squared. 2x and negative 3 is negative 6x. Negative 3 and 2 is negative 6x. And a negative 3 and a negative 3 is going to give me a positive 9, correct? Okay, so then when I clean this up here, this is negative 12x. You guys agree? And then when I distribute my 6, I have 24x squared minus 72x plus 54 equals, on the right-hand side, you guys agree I have 14x minus 21 plus 3. So 14x minus 18. Everybody with me? So since I have a quadratic, I have an x squared and I have an x, I need to move everything to one side. So I'm going to subtract the 14x and I'm going to add 18. So this leaves me, ladies and gents, with 24x squared minus 86x plus what? Plus what? 72 equals 0. Now, some of you are like, seriously? Right, I know. This is the hardest part of this whole day, is factoring this. Not Algebra 2 honor stuff, just a tough algebra factoring problem. What would make our life a little easier? Okay, let's take out a GCF. At least our numbers would get a little smaller. So if I take out a 2, I'm left with 12x squared minus 43x plus what? 36 equals 0. Okay, it's not going to get much easier than that. Now we got to figure this out. So first of all, tell me right now what 36 times 12 is. Don't take out your calculators. What is it? 36 times 12. 432. Okay, so yes, I am asking you guys to do this. I'm asking you to find factors of 432 that multiply to give me positive 432, but add to give me a negative 43. Now, how could you guys go about doing this? Yes, you could just guess and check. If I were you, I would take 432, and I would do our upside down division all the way through and get all the factors. It's just the same as a factor tree. You guys work that out. Come on. Ding, ding, ding. 16 and 27. All right, so x minus 16 and x minus 27. You guys can help yourself out. I know this number is large. I get it. But you guys can help yourself out with what I just said. Think about it. You're trying to get a positive when you multiply. So if you're going to get a positive answer when you multiply, both factors have to be negative, or both have to be positive. And then when you add those two, you want a negative number. That means they both have to be negative. Because a negative times a negative is a positive, but a negative plus a negative is a negative. All right, so what do I need to do in this case now? Divide both factors by 12. Are they going to divide pretty? No, but do they simplify? Yes, 16 over 12 simplifies too. Yep. And then 27 over 12 simplifies too. Mm-hmm. So you have 2, and then you have 3x minus 4, and then you have 4x minus 9 equals 0. So when you set all three pieces equal to 0, think about it, guys, at the very beginning. How many answers should I have for this problem if my highest exponent is a 2? I should have 2. So when I say 2 equals 0, is that a solution? No. But you can solve here. You get x equals 4/3 and x equals 9/4. Yeah? Okay. Now, are we going to go back and check this? No. I know you're not going to go back and plug both of these in, but if I plug either or both of them in, is there any chance that my denominator would become 0? No. So you guys are good. All right, that's the first half of the lesson. The second half of the lesson is 4 more questions, and it's so much easier. This is not hard at all. It's just a pain. I mean, it's a pain in the butt. I get that. All right, now we're going to talk about absolute value, absolute value, absolute value. Can you guys remind me something about absolute value? It's always what? Always positive. Can anybody tell me why? Tell me. How many spaces away from 0, right? So think about it. If I have 0 here and I have 5 here and I have negative 5 here. From 0 to 5 is how many spaces? 5. From negative 5 to 0 is how many spaces? 5. It's just the direction of which you go. So absolute value is always, always positive. The way that we solve absolute value is we are going to remove the absolute value bars and set the equation equal to the original and the opposite. Solutions have to be checked just to make sure, and there are special cases. Absolute value can never, ever, ever equal a negative number. So let's look at this. How do I know this is an absolute value equation? I have absolute value bars. So you're going to set up 2 equations. You're going to take the original, you're going to remove the bars and say, okay, 2x plus 1 equals 5. And then you're going to set up another equation that says 2x plus 1 equals what? negative 5. You always switch the signs. So on the left-hand side here, I'm going to subtract 1 from both sides. I get 2x equals 4. Agreed? Divide by 2 and get x equals 2. Easy enough, yeah? Okay, same thing over here. I'm going to subtract 1 from both sides. In this case, I get 2x equals negative 6. Divide both sides by 2, and I get x equals negative 3. Now, what do we have to do with our answer? You got to plug it back in and check. Do I need to see a formal check? Absolutely not. Let's do this in our head. I'm going to plug in 2. What is 2 times 2? Plus 1 is? The absolute value of 5 is? Okay, this one works. Negative 3. 6 times negative 3. Just kidding. 2 times negative 3. There's 2 times negative 3. Negative 6 plus 1. Absolute value of negative 5 is? So we're good. I hate when I ask you guys a question and then I answer myself with, it's a rough life being a teacher. All right, does anybody notice anything? Okay, the answer is already negative. Now, don't be fooled. Okay, some of you guys see absolute value, you're like, oh, absolute value can be negative, so there's no solution. Be careful, guys, that there's not like a negative hanging out in front of here, that there's not something being divided. Just make sure, make super, super sure before you just go, oh, this is no solution. I'm going to go ahead and set up my 2 equations. I have x plus 1 equals the original, negative 5. And then I'm going to take x plus 1 and let it equal the opposite, which would be positive 5, correct? So if we go through the process of solving, we're going to subtract 1 from both sides and get x equals negative 6. Okay, I solved it. I got an answer. I'm going to do the same thing over here. Subtract, and I get x equals 4. All right, so this appears to have 2 answers. But let's check it. If I take negative 6 and plug it in right here, what is negative 6 plus 1? Negative 5. Great. But what is the absolute value of negative 5? Does 5 equal negative 5? No, so that one doesn't work. Same thing here. If I take 4, what's 4 plus 1? 5. Okay, what's the absolute value of 5? 5. But does 5 equal negative 5? No, so that's no solution. If you, right off the bat, see that, okay, fine. I would like you to go to this length and say, hey, just let me prove it. Just let me show you why. Don't just put no solution, because then I think you're just guessing. Yes, sir?
For 7, 2 was correct, negative.
No, negative 3 works.
The negative 3 you get negative 5 equals 5, right?
No, you get the absolute value of negative 5 equals 5. What's the absolute value of negative 5? 5. So they both work. All right, 2 more, and then we're done. Then I'll answer questions from homework. Exact same type of problem, exact same type of way that we're going to solve it. We just have a quadratic. How many times are we going to solve this? Twice. We're going to write the original, so I'm going to take the bars off and say absolute original of how it's written. Then I'm going to take the bars off, x squared minus 3x, and I'm going to negate. I'm going to change the sign, but I'm putting this in parentheses. Why? I didn't put just the singular number in parentheses. Why am I putting the second expression in parentheses? Right, I'm going to have to distribute. You have to do that. If it's one term, you don't have to put it in parentheses, but if it's more than one, you have to. So on the left-hand side here, we're just going to say x squared minus 3x. I'm going to bring both of these over. So this is going to become what? Plus 4x minus 6 equals 0. Okay, so x squared plus x minus 6 equals 0. Does this factor? X plus 3 and x minus 2. So I get 2x values, negative 3 and x equals positive 2. Agreed? All right, let's plug it back into chat, guys. You need to check these. All right, so let's check. Let's plug in with negative 3. So I have negative 3 squared, right? Minus 3 times negative 3. Does that equal negative 4 times negative 3 plus 6? Everybody with me? All right, so negative 3 squared is 9. Negative 3 times negative 3 is, what is it? Okay, so plus 9. And then over here, negative 4, negative 3 is 12, and 12 plus 6 is 18. Okay, so I have the square root of, absolute value of 18 equals 18. True? Okay, so this works, correct? Everybody with me? I'm showing you how to check just to make sure you guys understand. So now we're going to try 2. So if I plug in 2, I have the absolute value of 2 squared minus 3 times 2. Does that equal negative 4 times 2 plus 6? 2 squared is, so I have 4 minus 6. And then over here, what's negative 4 times 2? Negative 8 plus 6. What's 4 minus 6? Negative 2. What's negative 8 plus 6? Negative 2. Is that a true statement? No. The absolute value of negative 2 does not equal negative 2. So does this one work? No. That's what I want you guys to see. I'm not going to recheck all of these as we go through just for sake of time, but you have to. But write it out. All right? With these quadratics, you might want to write it out just to see. That you could make a silly mistake right here by saying, oh yeah, that's true. Think about absolute value is always what? Positive. Okay, let's come over here. So I have x squared minus 3x equals what? What's the left-hand side or the right-hand side look like? 4x minus 6. We have to distribute. Now move everything to one side. Agreed? Okay. So x squared minus 7x plus 6 equals 0. Factors of 6. That'll multiply to give me 6, add to give me negative 7. Minus 1 and minus 6. So I have x equals 1 and x equals 6. We agree? One of these works, one of them doesn't. Tell me which one. All right, let's check real quick. I'm hearing both. So let's plug in 1. So I have 1 squared minus 3 times 1 equals negative 4 times 1 plus 6. Okay. What's 1 squared?
1.
Minus 3. So absolute value of negative 2. And then I have negative 4 times 1 is negative 4 plus 6 is 2. What's the absolute value of negative 2? 2. Does 2 equal 2? Yes. Okay, so this one works. What happens when we throw in 6? We have 6 squared minus 3 times 6, an absolute value, equals negative 4 times 6 plus 6. What's 6 squared? 36 minus what? 18 equals negative 24 plus 6. What's 36 minus 18? 18 equals, what's negative 24 plus 6? Negative 18. Does the absolute value of 18 equal negative 18? No, so what one does not work? 6. You've got to be careful. It's going to be tricky. If you're trying to rush and not pay attention, you're going to make a mistake. All right, last one. So I have, let's take the absolute value bars off. X squared plus 4x equals, just like you see it, 7x plus 18. And then I'm going to do it again over here. X squared plus 4x equals, and I have negative 7x plus 18. Put that 7x plus 18 in a parenthesis. You've got to distribute that negative. So on the left-hand side, we're going to solve. We have x squared plus 4x minus 7x plus 18 equals 0. So x squared minus 3x plus 18 equals 0. What are the factors of 18 that multiply to give me 18, but add to give me a negative 3? Should be my signs here. Should be what? What should my signs be? Minus 6 and plus 3, right? So x equals what? 6, and x equals what? Negative 3? Okay. Did you guys plug in and tell me what works and what doesn't? Negative 3 doesn't work, and 6 does? Are you for sure? I'm not telling you guys are right or wrong, but I'm trying to show you, you have to check. Don't just wait for Paul to do it. Paul, which one works, which one doesn't?
The positive 6 works and the negative.
I want everyone to check the next one. Everyone check the next one. I know we're running out of time. Check. I have x squared plus 4x. What does this give me now? Negative 7x equals negative 7x what? Minus 18. Thank you. So I have x squared plus 4x. When I bring 7x over, what does it become? So plus 7x. And then when I bring negative 18 over, what does it become? Positive. Okay, good. So x squared plus 11x plus 18 equals 0. What does this factor out to be? Plus 2 plus 9. So x equals negative 2 and x equals negative 9. Agree or disagree? Agree. What works? What doesn't? Okay. X equals negative 2 works and x equals negative 9 doesn't. Do you guys agree? Agree or disagree? Okay. For the sake of time, guys, I did not check every single one of them, but you have to. They're not always going to work. You have to go through, and you can't just check half-heartedly. You have to go through and actually say, does the absolute value of this equal what's on this side of the equal sign, and vice versa? Absolute value is always what? Positive. Okay.